Hey everyone, in today's episode, we are going to discuss web application firewall. I'm not sure where that belongs. Let's try to zoom in. Web application firewall. Is it in security? Security, identity. What is the web application firewall's shield? This is the shield. Security Hub, Secrets Manager, Organizations, Resource Access Manager, Network Firewall, Cloud SSH Firewall, Artifact. Where is it? This one. WAF, the Web Application Firewall. Okay, so if you have um, an AWS account, so this is your account, AWS account, cloud account, like that. And this is your firewall. And um, where is the S3 bucket? Okay, so you have your S3 bucket here, and then your CloudFront. CloudFront is here, your S3 bucket is here, then your CloudWatch, Cloud CloudWatch. Where is the CloudWatch? I think this one. Yeah, this is your CloudWatch. So where should we put our web application firewall? So it's here like that, and then your clients will be here, computer. Um, so you have your client here connecting to your CloudFront, and your CloudFront is sending logs to the CloudWatch, and also your S3 bucket will be sending logs to your CloudWatch. And where should we put our firewall? So the firewall will be in front of the CloudWatch. So your client should be hitting the firewall first, and then firewall will be going to the CloudWatch. Oh no, the CloudFront. And then your CloudWatch can also send logs to, your firewall can also send logs to CloudWatch. And yeah, that's it. You also have your Route 53. So your Route 53, so let's see. 53. Um, route 53. Okay, so I believe this, where's it should be this one, yeah. Route 53. So your client will be hitting Route 53 first before it sends traffic to the firewall, and then your Route 53 can also send logs to CloudWatch. And yeah, that's a firewall Route 53 So if you can read what is, am I recording? Yeah, we're recording this. So what is Route 53? What is Route 53? So Route 53 is a highly scalable and reliable domain name system web service provided by AWS. It enables you to route end users to internet applications by translating human readable domain names. Like for example, I'll put a text here. So like for example, www dot netist dot com, right? Oops. So the computers set here and then into an IP address. So it translates this into an IP address, into the IP address that computers use to connect to each other. So the Route 53 is the one responsible for translating. So let's just use an example here, example.com. The Route 53 is responsible for translating this to IP addresses. So key feature of Route 53, domain registration. So you can register new domain names directly through Route 53. So for example, it's like a GoDaddy service where you can register your domains. And for DNS management, Route 53 allows you to manage the DNS records for your domains, such as A records, C names, and MS records. Um, Traffic routing, simple routing maps a single resource to a domain name. Uh, Weighted routing distributes traffic based on specific weights across multiple resources. Latency-based routing routes users to the region with the lowest latency. Yeah, so that is also a job for Route 53. Geolocation routing routes traffic based on the geographic location of the user. Failover routing automatically redirects traffic to a backup in case of resource failure. It also do a health checks and monitoring. Continuously monitors the health of your resources and integrates with routing decisions. Oh, so Route 53 can also do health checking of your services. So, for example, if what if the firewall is not available? Does it check this one? Or maybe if you have an EC2, is this an EC2? Yeah, it's not the one. That's not the new one. Is this a new one? Yeah, I think this is a new one. So if you have an EC2 service that, um, yeah, we'll have the load balancer thing, and yeah, I'll just remove that example for now. So it will check for the health of your services, and it will make some routing decisions based on the resources health conditions. So for integration with AWS services, seamlessly integrates with services like Amazon EC2, S3, Elastic Load Balancing, and CloudFront. So in this case, like this, our setup here, we have the firewall in front of CloudWatch before Route 53 goes to the, no, CloudWatch, CloudFront. Okay. So scalability and reliability built to handle large volumes of DNS queries with low latency, domain transfers, transfer existing domains to Route 53 for centralized management, use cases, hosting websites or applications, setting up subdomains for different environments. So, for example, dev.example, prod.example, creating private DNS zones for internal networking within AWS. So, it creates private DNS zones. Okay, for internal networking within AWS, implementing disaster recovery and failover solutions. Okay, so that is Route 53. And what about web application firewall? Web application firewall. So, web application firewall is a managed service provided by AWS that helps protect your web applications from common web exploits and vulnerabilities, such as SQL injection and cross-site scripting. It provides customizable protections against web-based attacks while allowing legitimate traffic to pass through. Key features of AWS Web Application Firewall: rule-based filtering, predefined managed rules. AWS provides managed rules that protect against common attack patterns. So you have predefined managed rules and custom rules. Create your own rules to define specific conditions to allow or block requests. So in this case, we have a request here. Our domain is going to be translated to an IP address. Then it goes to the firewall. And then in the firewall, you will have predefined managed rules. This might be rules already created by AWS for you. And then you can also add a custom rule. There's also a rate-based rules, so it will protect against distributed denial of service attacks by limiting number of requests from specific IPs. Okay, so your web app API won't have to deal with this kind of um, scenarios in your code because we're gonna put a web application firewall in front of our API. And then integration with AWS services works seamlessly with CloudFront. Like for example, here they work seamlessly together. For application load balancer, we have a load balancer here. Okay, so I'll just put it as an example here. Load balancer ELB, ALB. What is the icon of application load balancer? Is this the latest one? There should be another one, right? Let's see here. Should it be in compute? ELB. I think this one, right? Yeah, I think this is elastic load balancing. So yeah, so your firewall will do something like this. You have an ALB here, and then your application load balancer redirects traffic to EC2 resources. And what else? API gateway. So let's see here, API gateway. API gateway. What is the icon of a gateway? Um, Internet gateway. Damn, I forgot. API. Is there any, or maybe here, compute, batch, Fargate. Jing, 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 jing. Container sets, not containers. Developer tools, front-end mobile, gaming, machine learning, security, API gateway. Where is that API gateway? Is it in serverless? No. API gateway. API gateway. Is this the API gateway? No, this is not the API gateway. What is the icon for API gateway? API gateway AWS icon. Yeah, this one. This is the API gateway icon. Where is this? See here, API gateway. Yeah, where is that? API gateway. Yeah, there you go. API gateway. So API gateway, like this. Oops. Have API gateway here, and then you have ELB, ALB, more results, load balancer, damn, compute. So you have your elastic load balancer here. Like that. Okay, so protect applications running in AWS without requiring changes to the application. Real-time traffic monitoring, logs, and analysis incoming requests to help identify patterns and potential threats. Integrated with AWS CloudWatch for metrics and alerts. Flexible security rules match rules based on IP address, HTTP headers. So you will have a rules here so that yeah, you can um, based on the rules that you've created, IP address, HTTP headers, URL strings, query strings, body content. It will make decisions based on those parameters. So bot control, detect, and block bots using AWS web application firewall bot control available as an additional managed rule set. Ease of use, manage console to create and manage rules, APIs for programmatic rules and creation and updates. Programmatic rule creation and updates, supports Terraform and AWS CloudFormation for infrastructure as code. Cost effectiveness, pay as you go pricing model based on the number of rules and web requests. Process, no upfront commitments. So use cases, web application application security, protect web apps from all WASP top 10 vulnerabilities, denial of service mitigation, block suspicious traffic to minimize downtime and resource exhaustion, compliance security requirements, met security standards like PCI DSS by implementing strict access control, bot mitigation, prevent scraping and automated traffic from affecting performance. Yeah, so API security, safeguard API endpoints exposed via AWS API Gateway or ALB. So it can, why is API Gateway not supporting this security off the right off the bat? Okay. API Gateway is designed as a scalable and flexible service to manage APIs, focusing on tasks like request routing, authentication, and throttling. It does include some basic security features such as rate limiting, authentication via Cognito or IAM, and logging. However, it doesn't inherently include the depth inspection capabilities that Web Application Firewall offers. Here's why: separation of concerns. API Gateway focuses on managing and exposing APIs, handling request routing, protocol translation, REST to WebSocket, authentication, and authorization. Web Application Firewall specializes in application layer security with robust capabilities to filter, analyze, and mitigate web threats, including this within API Gateway directly would make the service more complex and could impact its performance. By separating these concerns, AWS allows each service to excel as its purpose and remain scalable. Advanced web security is complex. Protecting against web exploits like SQL injection, cross-site scripting, or bot traffic requires depth packet inspections and traffic analysis. This task demands specialized rule sets, patterns, and algorithms that involve constantly to handle new threats. AWS Web Application Firewall is built to address this specific need. If API Gateway included full Web Application Firewall capabilities, it could lead to increased cost for customers who don't need advanced security, performance overhead for API requests, modularity and flexibility. AWS follows a modular approach, letting you pick and choose services according to your application's needs. Not all applications using API Gateway requires Web Application Firewall level security, so separating these services avoids forcing customers to pay for features they don't use. So for performance optimization, deep security checks are can add latency, which might not be acceptable for applications prioritizing low response times. By using Web Application Firewall separately, you can decide where and how to apply these rules, only for high-risk APIs or specific routes. Scalable and specialization. Scalability and specialization. AWS Firewall is designed to handle high throughput and perform real-time traffic analysis without inspecting or impacting other AWS services. Integrating AWS application firewall capabilities directly into API Gateway would require API Gateway to scale for both traffic management and security, potentially compromising one or the other. So, how to use Web Application Firewall with API Gateway? AWS encourages a layered security model where you can combine services, attach AWS Web Application Firewall to your API Gateway for robust threat detection, use API Gateway for authentication and rate limiting, then pass traffic through Web Application Firewall for additional filtering. Okay, so it will be API Gateway first and then Web Application Firewall after. So this is wrong. So it should be like that. API Gateway, then API Gateway goes to like that. And then Firewall goes to load balancers like that. And then load balancer will redirect traffic to EC2. Okay, so using API Gateway, all right. So this approach ensures security without sacrificing performance. Okay, so let's ask which should be triggered first. API gate gateway gateway or web application firewall. Okay, so the sequence of triggering API gateway and AWS web application firewall depends on how you configure them and the security requirements of your application. In most scenarios, web application is triggered before API gateway to filter malicious traffic at the edge of any entry point, ensuring only clean, legitimate traffic reaches API gateway. So yeah, um, our diagram, our previous flow is correct. So firewall first, then API gateway, and then API gateway goes to load balancer. Recommended order web application firewall to API gateway. Web application firewall is typically associated with Amazon CloudFront or API gateway. By associating web application firewall with CloudFront, if you're using it, malicious traffic is filtered at the edge locations before it even reaches API gateway. If CloudFront is not in use, you directly attach API gateway to a web application firewall to API gateway. In this case, web application firewall inspects traffic before it reaches API gateway. All right, so you can even use CloudFront. CloudFront also before it reaches here. Firewall, CloudFront, then API gateway. All right. So API gateway after web application firewall. Once web application firewall filters out malicious traffic, API gateway handles tasks such as authentication and authorization, throttling and rate limiting, request routing to backend services. Why should web application be first? Performance. By filtering malicious traffic early, you reduce unnecessary load on API gateway, improving its performance and reduce cost. Security. Web application firewall can block bad traffic. Example, SQL injection, cross-site scripting that might bypass simple rate limiting or authentication rules in API gateway. Cost effect Cost efficiency. AWS charges per request for API gateway. Blocking malicious traffic with web application firewall first reduces the number of requests API gateway processes, saving cost. When might API gateway be triggered first? In rare cases, you might want API gateway to be the first line of defense, such as you're relying solely on API gateways built-in authentication using AWS Cognito or IAM rules. Your application doesn't need advanced application real layer security features that a web application firewall provides. However, this setup is less secure as malicious traffic could reach your API gateway before being filtered. Configuring web application with API gateway. Direct association. Attach API web application firewall directly to API gateway using web application firewall with web ACL in the API gateway settings. Edge association. If you're using CloudFront, attach web application firewall to CloudFront and route traffic through it before reaching API gateway. All right, so that's it. The other thing that we want to check is the what else? Shield, shield. What is the icon of shield? I think this one. All right, so shield. Let's check for shield here. Shield, 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 shield. Jing, 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 jing. What's the icon for shield? Yeah, I think this is the icon of shield. Okay, so what is AWS Shield? Jing, 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 jing. Okay, so AWS Shield is a managed distributed denial of service protection service provided by AWS. It safeguards applications running on AWS against both common and sophisticated distributed denial of service attacks, ensuring high availability and resilience. Types of AWS Shield. AWS Shield standard, it's free, automatically enabled for all AWS customers, protects against common, most frequently encountered DDoS attacks such as UDP reflection attacks, SYN floods, DNS query floods, ensures minimum disruption and low latency mitigation without requiring manual intervention. AWS Shield Advanced, this is paid, provides advanced protection for complex and large scale attacks, includes enhanced DDoS mitigation, sophisticated attack detection and mitigation for volumetric and application layer distributed denial of service attacks. 24/7 distributed denial of service response team. So these are the paid ones. Access to AWS security experts for attack mitigation and assistance, cost protection, financial protection for scaling costs incurred during a DDoS attack, uh, detailed metrics and reporting, access to detailed metrics via CloudWatch for attack diagnostics, integration with AWS Web Application Firewall allows for customized rules to defend against application layer attacks. Key features. Oh man, this is a very long read. Automatic detection monitors incoming traffic and automatically detects denial of service attacks using specialized algorithms. Global coverage protects applications hosted on AWS regardless of the region. Integration with AWS services works seamlessly with CloudFront, ELB, Route 53, API Gateway, no maintenance, fully managed service with no infrastructure setup required. When to use AWS Shield, right? For standard, suitable for most applications with basic protection needs. Ideal if you're running workloads with minimal exposure to targeted distributed denial of service attacks. Advanced, recommended for mission critical applications such as e commerce platforms, financial services, and government portals. Ideal for applications with high visibility or a history of targeted attacks. All right, AWS versus web application firewall versus Shield. So AWS Shield focuses on network layer denial of service attack protection. The web application firewall provides an application layer security, SQL injection or cross-site scripting. Combination for comprehensive protection, AWS Web Application Firewall can be combined with AWS Shield Advanced. How AWS Shield works with API Gateway and CloudFront, Shield plus CloudFront traffic routed through CloudFront benefits from Shield's built-in protection. CloudFront absorbs the and disperses traffic to prevent resource exhaustion. Shield plus CloudFront, right? So traffic routed through CloudFront benefits from Shield's built-in protection. Okay, so Shield plus API Gateway protects API endpoints from volumetric attacks, works alongside AWS Web Application Firewall for application layer filtering, And yeah, that's it. That's for the web application firewall and shield. Um, yeah, I think that's it. Um, we have 35 minutes. Okay, so thanks. Bye.